Welcome to Brain Vision.
Hi everyone, this is the solution to problem 46, chapter 24 of God Knows Physics. So in this problem, we have a setup that you can see in figure 24.24 in a textbook. And so the first thing that we are told is that when we have this situation that you have an unpolarized light coming in from the left, goes through a vertical polarizer, then goes through an insertion, and then goes through an analyzer, the intensity that reaches the cell is 110 watts per meter squared, when the angle of the insertion is 23 degrees with respect to the vertical. So let's go through what happens and how, what is this S bar cell in terms of S bar 0 as we go through each step here. So first of all, you have unpolarized light on the left, right? So then as you go through the first polarizer, you're going to have an intensity that is going to be a half times S bar 0. This is just because you polarized and unpolarized light. Now, as you come in to this section over here in the middle, or between the insertion and the analyzer, you're going to have that the intensity here is going to be the intensity that you had before. So the intensity incident on the insertion times an angle theta cosine squared times that value. This is the reason. The reason for this is that the light incident on this insertion is polarized parallel to the vertical axis, and the axis of polarization of the insertion is making an angle theta between with that axis of vertical polarization. So this is the value that you have going on to the analyzer. And so the thing that comes out on the other side of the analyzer is what the photocell actually picks up. So here we're going to have S bar cell. And so this is going to be equal to the intensity that you had coming onto the surface here. So red S bar. And this is going to be multiplied by the angle that this theta angled polarization axis makes with this horizontal polarization axis. And so you can either write that as cosine squared of 90 degrees minus theta, or you can write it as S bar sine squared of theta. These are completely equivalent, but plugging in all the values from before, you see that, or you like following all the substitutions that you've made before, you see that S bar cell is equal to S bar 0 half times S bar 0, right? This is just from this comes from the polarization of the unpolarized light. Then you have this value times cosine squared theta. This comes from the polarization through the second polarizer, the insertion. And then this, what you have here right now, is this red S bar, and then you still need to multiply that by sine squared theta to get the intensity that actually reaches the photocell. So what you can do is you can use this to find what S bar 0 is, and you see that this is 2 times S bar cell divided by cos squared theta sine squared theta. So this is what S bar 0 is. And the reason why you want to work this out is because you want to find what would be the intensity reaching the photocell if the analyzer was removed, so if this last part was not here. So let's take a look at that scenario. So here we have, again, S bar 0 is equal to 2 times S bar cell from the first scenario, which we're told the value of, divided by cos squared theta times sine squared theta. And so now we want to find what this red intensity is. So again, going through step by step, we know that the blue intensity here is going to be 1/2 times S bar 0, just because you polarized the unpolarized light, and then you subject this electromagnetic wave in the middle to an other polarization through an angle of theta, but it was already polarized. So you find that S bar in this scenario, which is S bar cell prime, let's call it that, is going to be the blue intensity times cosine squared theta. And now plugging everything in, you find that this is, let's go over here. So you have S bar is equal to 1/2 times S bar 0 times cosine squared theta, which is actually 1/2 times cos squared theta times 2 S bar cell over cos squared theta sine squared theta. And so the 1/2 and the cos squared theta cancels the 2 and the 1 over cos squared theta. And you're just left with this being equal to S bar cell over sine squared theta, which is equal to 720 watts per meter squared. And so this is our final